All right, welcome everyone. I'm Jeremy Baumang, outside sales with Baywa RE Canada, and continuing education is important to Baywa, so we really appreciate you attending and taking time out of your busy day to join us and S5 metal roof attachments. Thanks for joining us, gents. Just a reminder that this will be recorded. You'll be able to see it on our YouTube channel, and it will also be released during our next monthly newsletter. Please sign up for the YouTube channel. If you haven't already, you can find all of our past webinars there. And if you have any questions during the webinar, be sure to type them into the chat box in the bottom right corner of the portal. We will answer questions as we go, and we might have some time at the end of the webinar as well. So without further ado, I will pass things on to Brandon first from S5. Brandon, thanks for coming.
Great, thank you for having me, Jeremy, and thank you, Baywa, for having our team on today to discuss the topic we're going to be talking about today is the cost savings when it comes to installing solar on metal, and especially using the direct attach system. So we are going to start here. Let me just do a quick introduction. You all can see my screen, I assume here. So let me see if I can switch here. Is it sharing? Yeah.
Yeah, we can see it.
And how do I change to the next screen here? Oh, there we go. Okay, so let me just introduce my fellow guests here, presenters. So we have with us Mark Guys. He's our Director of Strategy and Market Development. Mark has, I guess, almost a couple decades in the solar industry, and has vast amount of knowledge when it comes to all of this, and will be the one sort of getting into the weeds with a lot of the actual wire management and the planning and sort of the industry knowledge behind it as well. And then we also have joining us Mikkel Sida, who is our US and Canadian application engineer. And Mikkel is based in Calgary here, so he's local, close to a lot of you guys there at Baywa. And so he's going to be discussing a lot to do with our testing. I'm going to talk a little bit about testing, but he's going to go in and actually show how the engineering and is actually run on these projects and how the design is run through the calculator. And he's going to sort of finish off our presentation here today, talking on that and some of the projects that he's been directly involved with. So I kind of wanted to start out this whole thing, and as I mentioned right off the bat, is that we're talking about metal roofing. So S5, we come from a background of metal roofing, and so this is what we are talking about today. We're not talking about flat roofing or shingle. We are focusing on metal roofing. And as I'm just going to touch on a couple of, well, actually the main types that we deal with and see a lot throughout the industry. And so the first one we're going to touch on is something that you guys are probably familiar. You see it out there, the standing seam. And the benefit of the standing seam is that it is a closed, sealed, fastened system. So it's a concealed fastened system. It has a clip that is located underneath the metal roof panel. And you can see here, sometimes they'll have it as what's called a floating clip. That floating clip will allow for thermal expansion, and that's just part of that system of that metal roofing. This is a mechanical seam, so once that fold is created, you'll have a watertight seam without any penetrations in that roof. And that's the key to the quality and, I guess, durability of this type of metal roofing system. And so you can see here, manufacturers over the years have provided, and engineers have designed several different types of profiles, which again, we work closely with these manufacturers to develop the clamps. And I'm getting to this and talking about this because this leads into our whole idea of using a direct attach system. So we developed clamps, and these are used in coordination with the direct attach PV system that we have, that creates the or actually eliminates the need for a rail-based system, because your attachment points are connecting directly to the clamps, connecting directly to your seam profile. Then we have the other type of metal roof is your exposed fastened. So you'll see this a lot in agricultural uses. It's a little more economical. At these types of roofs, you are putting fasteners through it, so the penetration is not the issue on this. It's going to be whether it's in structure, and there are other testing facets that you need to be concerned with, such as water leakage. So when it comes to this, we look at the different varieties of the other types of exposed fastened metal panels that are out there, which are the corrugated. You can see there in the bottom right corner, bottom left corner, the R panel type agricultural panel you see a lot at the top there, and then you see the insulated metal panel on the right there, and those are both exposed fastened and can be standing seam as well. Those are the main styles. We do have solutions for this that will work with the direct attach system, and is sort of the base of that direct attach system. Again, and Mark will get into, and we'll all sort of touch on the fact that it's using the ribs or the seams in a sense as your rails. I'm going to mention a little bit on the testing aspect before it's shown in application with our calculator. But a big part of our company is the testing aspect. A big part of it is the circle of certification, the triad of quality assurance. We're making sure from manufacturing to engineering, and that's in terms of product to design and actual testing. And you can see here, these are a couple of the areas in which we test and methods in which we test, which is negative load normal to seam, which is an pull-up test, and then also the parallel to seam, which is more used for other product applications, heavier duty snow type applications that we have. In terms of the testing, and again, this is all going to tie back to the direct attach system and saving money overall with the solar array, because the clamp to seam is the important part of, again, the holding strength and warranty and everything that's involved. This is a quick snapshot just showing that we take, even from the touch point, into consideration, that we're making sure that you can see on the left here, that's a traditional way it has been done with cup point type screws, which can damage coating. Whereas on the side here, on the right side, you can see it's a bullet point screw, which we use, a round nose screw, and it creates a dimple and doesn't affect the coating. We also, for the exposed fastened, we've created our own fasteners in conjunction with to be compliant with the watertight testing, which we can show a diagram here and later a photo from some of the laboratory testing that we're doing. And we're also testing in other areas as well, and this ties into some of the concerns that we hear from, well, if you're attaching, what about wind uplift, what about heat? And we'll address some of those things, but the wind uplift is tested. We do the pull-up testing, and we can see here we do rail top mount versus side mount, and some of the differences between that, head-to-head pull-out tests. We do the pull-up tests, you can see here, with the direct attach system. So all of our products are thoroughly run through the engineering testing system in order to make sure that it is compliant with the codes that are out there that we need to make sure that we're compliant with. And there's a handful. We continue to add to this. We are compliant with several of the, well, obviously the Building Code of Canada, and we have ULC, and continue to get those, any sort of standards that we need to comply with. So I'm going to talk about a little bit about the perfect match between metal and solar, and people will, a lot of times this question doesn't come up till maybe too late, and we'll have somebody put a solar array on the roof and then realize that the roof needs to be replaced. So the biggest sort of factor when it comes to why is this a perfect marriage? And you look at the mean service life of a typical solar PV array, And if you are, you know, when you're looking at this is an older statistic, so you can see some of those numbers have moved up, but overall relatively have still maintained that your best substrate to have under your solar array would be a coated steel, because you're never going to have to replace that roof, remove the solar array, reinstall it. You're going to lose any of that potential return on investment, or at least it'll set you back. So I think Mark is going to go a little bit deeper into that sort of head-to-head comparison. But this is a good one, just showing why coated steel and metal roofs outperform in terms of its compatibility with metal roofing, or sorry, with solar arrays, that it's going to perform better in the long run, because you're not going to have to replace that roof system. And this is another factor here we'd like to take into consideration, is that when it comes to the different types of roof materials that are out there, and you look at what you're up against, you've got TPO, you've got shingle, you've got a lot of materials that are not necessarily the most sustainable materials that are out there. Now, albeit they are continually improving, but metal still is one of the only materials out there that is really truly 100% recyclable. The recycling rate is lower than that. Not all of it ends up getting recycled, but still there's a lot less metal in the landfills than there are with the other types of systems. So we always tell them to take that into consideration if it's a new build, or they're in the design phase of a building and the idea is to have solar. We always tell them to keep this in mind. Here's a couple. I'm going to look at a couple quick projects here that are, we'll look at a couple in Canada, a couple internationally, that are that direct attach system. And with some of our assistants, with Mikhail's assistance, with Mark's assistance, and I was on this job here, which was quite an impressive job here in Toronto at the Lumber Lost Place, and a couple that you'll recognize here globally that we've participated in with that exact direct attach system. So it's been time tested in the field. We've worked on some pretty major projects here, and you can see that once we have gotten people into that whole mindset of thinking about that roof design with using the seams or ribs as your rails in replacement, you see that the install time gets improved, overall cost of the project is diminished. And again, Mark's going to show some comparisons. So you can just see here the Gemini Observation Center, that's in Hawaii. Amazing. There's a great video online that's showing the install of that. That's out in BC, a municipal building. This is a barn dough in BC that we were part of the install and design phase of that, which was a very neat project. This is in Colorado, where they've used it as a wall application. Again, using direct attach, you wouldn't be able to do that with a rail-based system. And finally, we're going to end off. Mikhail's just going to touch a little bit on this snow and solar, because as you guys are, your headquarters is based in snow country and up there in Edmonton and in Calgary. So we like to sort of have those considerations in mind as well, because your solar panels are acting exactly the same as a metal roof in terms of your slippery surface architecturally. And like I said, Mikhail's going to touch on that. So I will leave this up at the end. If you do have questions throughout the presentation, feel free to mention it. If it's a quick question we can answer, we'll address it. If it's more of a discussion, feel free to reach out to us individually and we can have that discussion. And from there, I'm going to hand it over to Mark. Thank you.
Thanks, Brandon. Thanks, BayWa, for having me. Okay, show my screen. So do you guys see the presentation?
Yes.
Okay, and you hear me all right?
Yep.
So I'm going to show this. This is actually a couple years ago. We put solar on our own headquarters. This is in Colorado Springs. Pikes Peak is in the background, a little bit off the screen, but it's there. And I want to pull ahead a little bit of the content just to get this out front, is that the best way to install our system is to install column by column. And what I call a column is the modules that are running up the roof, that column. You can see this one's half finished. So really the best way is to start at the bottom and work your way up. And we'll get more into those details. Also, this is a good picture because it also shows snow retention, which Brandon just mentioned. So, this is in snow country as well. So we, kind of mixed up and utilized our product as well for the snow retention side to prevent snow from hurting people down below. And that's definitely a common concept throughout Canada as well. All right, so, oops, can't do this. So I'm going to just quickly go over the key benefits of our direct attached PV kit. It comes partially pre-assembled. The pieces that you see below, there's an end and a mid. That's it. That's all it is to build. It's versatile. It adjusts for clamp height for different module widths from 30 to 46 millimeters. You just need one tool to install it at T30 Torx. A lot less weight than rails. We'll get into that in a second. And another big part is that as far as point loads on the roof, there's generally tends to be more touching points to the roof with our product because it is direct attach. So it's just better on the roof. It's lower point loads and safer on the roof. And we'll get into this. The key difference is that these clamps go on the fly. So you're not measuring, you're not installing these ahead of time like you would rails, and that's where your time savings come into place. So here's the main summary. So if you're just thinking about racking only and the mechanical installation, we're not talking about modules, inverters, we're not bringing this into it. So the racking material is up to 40% less cost because you're going from rails to individual pieces, basically. That's the bottom line. The installation time, which we'll get into, is a key one. When you're rocking and rolling, you can do a module every 2 or 3 minutes with this system, and that just saves a ton of time. And you're not preparing those rails ahead of time, which is key. And then the key thing is shipping costs and logistics. You're not handling rails. So all in all, considering the mechanical installation and the racking portion of it, that could be upwards of a 40% cost savings. So this picture is a kind of a combination of a few slides just to get to the point. This is materials, shipping, and logistics. So on the left is rails. You can see all the parts. It's a pretty big bill of material. Not only is the rails, which is the main part, the weight, but also just a lot of complexity to all the other parts involved. And with ours, it's very simple. So this is 250 kilowatts of rails, and this is 250 kilowatts of our PV kit in the back of a truck. And those have to get shipped out. This specific trailer went from Boston to California way back when I was in that space, and then you have to have a crane to operate it, a crane op to get it up on the roof. With our product, you don't have to do that. Key advantage. So this shows all the rails. So every one of these rails has to be installed ahead of time, measured, put in, installed before a single module can be brought up on the roof, basically. So all that time is just really non-existent with a railless system, as you can imagine. The circled area kind of highlights that's a rail. I'll show you another contrasting picture in a second. But basically, the rails are not there for structure. I mean, the roof is handling the load ultimately, but what the rails provide is the rails provide just the attachment method. So, the modules are perpendicular to those rails. The modules are slid up, tucked up against the next clamps over, and then clamps are put in and they can infinitely adjust on that rail and then clamped, and then they get clamped down. That's how that works. Now, here's railless. Here's railless. So the key thing is that the rails are there already. So why do you need to put rails on top of rails? That's one of our big messages. And you can see that circled area. Think back to the rails. So those seams are acting in the same exact way as rails act. The modules get tucked up to the clamps above it, and then the clamps below the PV kits get pushed up, and you have infinite adjustment along the rail. So that's that's the main difference. So whereas you saw all those rails put in ahead of time for rail system, for a direct attach, this is it. So you have to put the first row of clamps in place to start the process. but that's really it. There's no more prep up there, up on the roof before you can start building. So you can pretty much jump on the roof pretty quickly your first day up in there to start building. So this video is kind of highlights from our own headquarters, and it's going to highlight a few things. You're going to see that snow retention on the edge. You're going to see the string line, which really starts your first row, and then the columns build up from there. Another key thing is that all this stuff, the pre-assembly, should take place on the ground. You can put them in boxes, bring them up by boxes. It's very simple. You'll see that. And then you'll see a quick snippet of the installation, which is the best way. As I said, you build the column up, you put the module in first, nose first, into the clamps in front. Then as you lower it, you do whatever clipping you have to do, whatever connecting of strings, and then you lower it the rest of the way. The next modules come up, the next clamps, I'm sorry, and those get adjusted in. So on the fly, you're putting the PV kits on. No measuring is needed. The module is the jig. So let's watch that video.
Imagine the convenience of fitting all the necessary components for attaching a 50 kilowatt metal rooftop solar array in the back of this. With the S5 PV Kit railless solar mounting solution, you get a system that weighs up to 85% less than a similarly sized rail mounted system, which not only saves you big on shipping costs, it also greatly simplifies the installation.
So here's the installation.
See how much you can save on your next metal roofing solar project by visiting s-5.com/pvkit today.
Okay, so I'm going to jump into some more of the nuances of this. And one of the big ones is, how do the seams and ribs fit with the modules? So as you know, modules have loading zones. So these are zones provided by the module manufacturers. This is an older picture, but it highlights, I think it's a good picture that shows the colors of where you can attach, basically. So, those are set, they may differ from module to module, but they're similar, basically. So you have, your primary areas where you can load, and then there's secondary areas for lower pressures. So you have those dimensions, right? And now you have the seams and ribs. So a seam spacing can be between 12 inches and 24 inches. Typical, they could go bigger. And then exposed fasten roofs, which Brandon had talked about, it is smaller. So those are maybe 6 to 12 inches, and then corrugated is even smaller. As you know, those are pretty tight waves of corrugated, and the tighter the better, because actually the tighter these ribs are, the more options you have for matching up. So it's basically, it becomes a geometry problem. You're trying to match up your loading zones with the available seams, and we can help with that. So McCall, we do that all the time. We spend a lot of time helping customers figure out, okay, where am I going to line up my modules, and then where should I put the clamps? So we can help you with that. It's pretty simple stuff. This is an example of an installer who really likes to install this way, because you have these correction gaps that we call them, because in order to hit the loading zones, you may have to sometimes reset. And if you're lining things up with midpoints and edges, you may have to reset. And these are 72 cell modules, 24-inch spacing. This guy loves to install that way, where two are tight together, and then you have somewhat of a correction gap, but he uses it as an O&M aisle. So not only does that improve your installation, but also any O&M later on, it's very easy to access that. I mean, we definitely acknowledge and know that people like to put as much on the roof as they can, but as well, having some of these spacing and aisles here and there really can help, really help down, the labor for O&M and down the road. So these are also a good idea. And this next picture shows some, in most cases, you can figure out around them. So these do have correction gaps, but you're only losing less than 1% of the available space on the roof. So it all can work out. Again, we can help you with this geometry. It's, like I said, it's basically a geometry problem you're trying to solve, and it's doable. And we talk to module manufacturers all the time as far as where the locations are and getting approval. So we help a lot with that, but it's not that difficult of a problem. Don't let that stop you. So, probably the biggest difference between rail and railless is wire management. With rails, that's the default. You zip tie jumpers, zip tie stuff to rails, easy. those aren't necessarily the best practices, but that's kind of what is done. You can't do that if you don't have rails. So, here's some best practices around that. And the two main things that I talk about is module prep and what I call strategic string design. So let's talk about module prep first. Basically, you want to do all the work on the ground or in a station on the roof where you have sawhorses set up, or it's vertical leaning up against something, and you tuck up all these wires. So this is an example of your conductors being clipped up so that the conductor ends are exactly where they need to be. So when you're installing on a roof, you're not having to reach under. It's easy to plug those things together, your strings together, and then you install from there. As I said, the best thing to do is put the nose in first, connect what you need to connect, drop it, put the PV kits, and then back up and move on. So this is an example of that. I'm showing you more examples of that. If you bring optimizers or microinverters into the space, attaching them to the module is also pretty commonly done. With optimizers, it's still DC, so you connect your conductors to the optimizer, and then the optimizer becomes what you're stringing. You're basically stringing the optimizers, so it's the same thing. So these are set up, so if I put one on top of the other to do my string, they just plug right into each other, and it's very simple. You're not reaching under. So this is really important to figure out where I want a repeatable process. You do it on the ground. You have a few people doing that, keeping up ahead of everybody. It's really important process to do, but it's simple. I mean, this is not anything different than what you guys see out there anyway. So here's another one. This is a microinverter. This is back to our own headquarters. This is an N-phase microinverter. This is all done on the ground before it gets up on the roof. So on the roof, all they had to do was put it in, plug in the trunk cable, which is on the roof ahead of time. I'll show a picture of that later, and then you're good to go. There's no extra work. Once it's down and in place and connected in, you don't have to reach under. This is a dual optimizer, so it's already plugged in, but there was two conductors coming out from the module in front of it. So when they put that one down, they reached under. That woman reached under, plugged them in. You can see now there's 4 leads that are plugged in. And then boom, they just continue with the installation. So the key is putting your MLPE where you want them, clipping your conductors and where you want those, and having those conductor ends exactly where is needed in a repeatable way, so that people on the roof can just rock and roll. So this is an optimizer. This really shows the circled areas, show the stringing. So this optimizer has a short output, has a short stubby conductor and a long one. That long one goes up over the guy's, right by that guy's hand, up over. So when you put in the next one, you're going to reach back, grab that one, connect it to the side of the module, and then plug it in and go. So this just highlights how simple this can be from module to module as you're laying it down. Am I running out of time, Brandon? Okay.
It's at 30 minutes.
Okay.
We're halfway.
All right, I'm getting there. All right, so the second key thing is strategic string design. So what you want to do is you don't want to just lay strings that are sequential, because what you end up doing, and this is good practice anyway, is you end up having a lot of these jumpers, what I call under module jumpers, that now have to be routed to the perimeter somewhere where you can use a wire tray or get to your home run. But all these pluses and minuses under here all have to be connected to a jumper and routed to the perimeter. So there are just simple ways to think ahead to say, okay, this could be a two-way street. You can match up an inverter so that the strings are exactly the height of the column you have, or you could design columns and aisles that end with where your optimizers, where your strings end, so that you always have your conductors on the outer towards the perimeter. On the residential side, it's not that big of an issue. I was just showing you as you built up the column, if you have a jumper, you can clip it on the side as you go and connect your strings together. So this just shows the routing of just a few strings on a residential project. And basically the jumpers can you finish this column, and you can just clip the jumpers up as you go. So it's a really simple way to do it. A lot of these just have soft, conduit EMT or soft conduit for the home runs themselves. So on a commercial project, that's where it gets more difficult. You just have a lot of strings in a stub array. Again, minimizing that distance to the perimeter is key, and being strategic about it. So in this case, they would build a column, and then that jumper would then, this is like a pass-through jumper basically, would then be clipped up on the side, and you just kind of build and clip up as you go. This is commonly done, very simple. That picture I showed with the stringing as well, you can just, there's clips you can get for the short side of a module, even if it doesn't have a flange, and clip up as you go. This shows sort of various ways and sort of nirvana where all the conductors ends are at the perimeter. So and they actually broke it up into an asymmetrical subarrays so that you can get those aisles, so you can do the plugging into your jumpers and running those with a wire tray to your home run. So we can help with that. It's amazing how when I talk with folks and we look at an array and change things around, how much the improvement, and everybody's very happy with it. And even with Rails, these same best practices really help as well. And it's common to have one column with a string, and you have a pass-through jumper underneath it, and that's a really good way to go with direct attaches as well. And I can talk more about it if anybody wants to talk to me. So another way that we've seen this done is with bigger subarrays, is using actually a wire tray underneath the modules, because there is some space with some seam heights, and if you can get really low profile wire trays, this works. Not in all cases, but basically you run a wire tray underneath, and then you just dump the jumpers in there, and then once they're in the wire tray, you don't need to do anything. There's no clipping or zip tying or anything. And that picture at the bottom actually shows a rail project, a pretty sizable rail project, that they actually used wire trays as well underneath, just to reduce that work of zip tying. So it's a good way to go. I think the simplest way is back what I was showing, where you just want to run these things up the side of a column and clip tie as you go, but this works as well. Here's some pictures of it. Here's the wire trays before. You can see the first row of PV kits as well in this one they're about to start building. This is a big system, so you can just see the home runs, and then there it is with the wire trays in the basket, in the conductors and jumpers in the wire trays after. This shows a trunk cable. So with microinverters, you can't just string them together. You have to use a trunk cable, as you know. So in our case, this is going back to the headquarters. We put the micro on the module, on every module in the same place, ran the trunk cable up the column ahead of time, clipped it up off the roof with a clip with our own clamp. And then as you go, you put a module in, and then as you're dropping it in, you plug the trunk cable in, and you're good to go. So I'm just going to show a few pictures. These are sort of my comic relief pictures, just showing, just with steep slope, it is difficult. And people tend to use the rails as stepping, to step on, and basically as ladders and scaffolding, which is probably not the best practice anyway, but you can't do that with PV kit. I'm not going to dwell on this, but basically putting scaffolding on the side as you build, if you build the column up and put scaffolding on the side, this is just a ladder that's clipped up to the top that slides over as you go. It makes a huge difference. You can install the same way you would install, just have a few people on the ladder and maybe somebody above, and installing it, and you go up the column, you move it over, build up the next column. It's really a simple solution to not having rails to step on. So this is actually that roof solar project that Brandon showed earlier. The same thing, that they're putting it in, ready to put it in, they're clipping it in, and they're going to back off and drop it in.
Just wanted to mention something real quick. I did show the picture of that lumber loss place, and I didn't stay on it long enough, really, because they built the whole structure. They did top down, and Mark's talked about that as well, when you install from the top down and what that kind of looks like. So they built that whole fall rest system in order to do that, because it was so high up and steep slope and whatnot.
What we see commonly, it's important. The thing is building a column at a time. And it's important, and commonly people go bottom up, but yes, as Brandon said, there's some cases where top down worked, and they had scaffolding that they moved up and down that you saw in that picture actually. So they were standing, putting it in, lowering. So there's some advantages to top down actually, and those guys took advantage of it, but it's a little bit more complicated. So I'm done now. McCall's going to jump into some of the details of the services we provide with our solar calculator.
Okay, can you hear me?
Yep.
Okay, so as you probably know, this is the same as with Rails. So every system has to be designed to site-specific conditions. So it has to be designed to the wind load, snow load. It has to be designed to geometry of the roof. Mark, I think I lost your slides.
You need to share, yeah, those slides, the calculator slides.
Can't see my slide. I'm still presenting.
It went away.
And
Change presenter.
okay, here we go.
There you go.
Okay. Yeah.
So we can help with this with engineering and calculation for our system. We actually can run the calculation according to National Building Code of Canada, which is obviously applicable in Canada. We might need more information from you, but this is actually the same as with Rails as well. So as I said, we need to know the geometry of the roof, if it's a gable, single slope. We need to know the height of the eave of the roof because that also influences the wind pressures on the roof. We need to know the dimensions of the roof, so we can actually determine the wind zones of the roof. As you know, there are different wind zones on the roof with higher pressure and with lower pressure. So that also is going to affect number of points of attachment in these zones. If you have available architectural drawings or even structural drawings, even better. Those can help us. Those can help us as well. And then what we also need from you is what type of solar modules are you going to be using for your project. We need to know at least dimensions and weight. If you can provide data sheet, even better, so we can also check the solar installation manual to see the mounting zones. You can go to the next slide, Mark. And then we also need to know the site-specific conditions. As I said, we need to know the wind load and snow load. If you don't know those, we can also look it up for you. So we will need to know the exact location of the project. If you have structural drawings available, that can be also helpful because it's already determined on them. So yeah, once we know all of this, we can. I think we can go to the next slide, Mark. So once we know all of this, we can run the calculation, and based on those calculations, we can determine how many points of attachment per modules or per side of the module you need. Then based on that, we can prepare bill of material for you, and you will just send that bill of material to BayWa. They will prepare the quote for you, and then we can also help with, which is on the next slide, we can also help with, so we can also provide the entire report. This report can be, if engineer of record is involved in the project, he can review actually every step, how we actually determined those number points of attachment. And then on the next slide, you can see that we can also help with the roof plan. So where is also determine the wind zones and also how many points of attachment you need. So we can help also with this layout. This is all free of charge. So do not hesitate to reach out to us. We'll be happy to help you with this.
All right, so now can you, I guess, give them a call control?
Okay, can you see my screen?
Yep.
Okay, so I would like to show you the project I attended, and I trained one of installers in BC how to use our PV-Kit. We can also, if you are a first-time PV-Kit user and you're worried that it's a new system for you, and that's the barrier that's the barrier you don't want to use it, we can help with this to overcome this barrier and train you and help you to overcome the learning curve. So this was a project in BC, Port Hardy on Vancouver Island. It was 90 kilowatt projects. It was exposed fastened roof, PBR panel. So we used re-bracket with PV-Kit on this project. So actually we used 378 rib brackets, 84 PV-Kit edge grabs, 294 PV-Kit mid grabs. They used 168 Jinko solar modules, and they were using rapid shutdown devices for this project. So this is what I was talking about. We can prepare the layout for you. Where you can see the wind zones determined by the calculation, and also points of attachment. We can also help with the string design, as Mark mentioned in his presentation. The string design, it's slightly different and requires slightly different approach. So the best way is to follow the path of installation. So once you start from the eave, you're going to the ridge, building the columns. The best way is also to follow this path with your strings. So we also help with this. This is the preparation phase. That's what also Mark mentioned. You can do this on the ground. So you can see here they prepped all the, they did wire management of those modules on the ground. Some people tell us that they prefer to do it on the roof because they can actually put the whole pallet of the modules on the roof. You can do that as well. So we will just put a whole pallet on the roof, and then one person can be just prepping them on the roof. It's that if it is more convenient for you. The advantage of this is that you can do this on the ground and you spend less time on the roof. Here is another example, the preparation phase. What we also did, we prepped the PV kits on brackets. This can be also done on the ground or even in your warehouse. So this also saves a lot of time. In this case, it was on Vancouver Island, so as you know, it's kind of humid in the morning there, so the roof was wet, and we were able to go on the roof probably around 11 a.m. So we actually spent that time from the morning, from 8 a.m. Prepping the solar modules and also PV kits. Otherwise, we would not be able to do that. We would need to have the late start of our work. So this is another advantage of PV kit. And as you can also see, you just prep those in the box, and you will just simply bring those boxes on the roof, which also saves you time and probably also logistics, money on logistics, because it's much easier to bring those boxes on the roof than bulky rails. On this slide, you can see we also practice first how to attach that bracket to the rib of the module before we attach it to the real roof. So this is showing the detail of PV kit and rib bracket. So this is the detail of rapid shutdown devices. You have to be also careful that these rapid shutdown devices or microinverters, they are not in collision with the PV kit itself. So in this case, we had to shift them slightly to one side, but it took us like, I don't know, probably 10 seconds. So it was not a big deal. And this is the start of the project. This was our first day. So there is a learning curve. First day was a little bit slower, but we had to also do the measurements. We had to install the first line of the brackets and PV kits here. We had to make sure that that line is straight. So there is some learning curve, but this is already a second day. So we picked up the speed, and there was three guys on this crew. So 2 people were installing the modules. Third person was distributing the solar modules over the roof. You don't have to do it this way, but he just didn't want to pile them up on one spot, so he just distributed them at approximate spots where those modules are going to be installed. And this was yeah.
Sorry, just one question popped up. You might have touched on it a bit, but what are folks doing for bonding and grounding in these installs here?
Yeah, so maybe I can show you on this slide. So this PV kit disk, it created support and platform for module frame, and this PV kit disk is also UL listed for bonding and grounding. So all the modules in one column are bonded and grounding through those PV kit disks.
Yep.
And then you just have to use. We have the product bonding jumpers that can be used for bonding 2 columns between each other. So hopefully
at the top and bottom.
At the top, yeah, that's what we recommend.
Perfect. Thanks.
Those can be clipped on the module frame. So this was second day. This was the end of second day. So we picked up a lot of speed. And actually, I have a video here, like a time lapse. So we were able to install 1 solar module under 3 minutes. We were still, as you can see me here with the black hat, I was still shifting those rapid shutdown devices slightly, but as I said, it took me like 10 seconds to do it. As you can see here, this guy with the white hat, he was doing wire management. So he was actually clipping the trunk cable on the side of the modules. So yeah, we were really fast once they learned the system and they got organized. And also you can see here that the best way is to start from the eave and going up to the ridge. And this is the final product. So do we still have some time? I can touch base a little bit on snow retention.
You got 10 minutes, I think.
Okay, so as you are in the snow country, you'll probably come across the project where will be also snow retention involved. There might be snow retention already installed on the roof, or there might be a requirement that they will need a snow retention in the future. So solar array actually has to be designed in coordination with snow retention system. So as you can see, this on the right side is our PV kit. So this would be actually approximate height of your solar array. And on the left side, you can see our lowest profile snow retention system, ColoGuard. So we are not just in the involved in the solar industry, but we also specialize in snow retention system. So we can actually give you good advice on both or coordination of both. So if you have your solar array with PV kit about the same height as our lowest profile and probably most and also most cost-effective snow retention system, in that case, you will need to leave the gap probably 3 to 4 feet between the snow retention and solar array, because you have to realize that with the solar array you are creating new roof surface. That's why if you put that snow retention close or next to the solar array, it wouldn't do anything. However, if you use a taller snow retention system, you might be able to go with the snow retention a little bit closer. Very likely you would be able to fit one more row of the solar array as well. But however, if you use a taller attachment solution or rail-based system, in that case, you need to also use the taller snow retention system. So in this case, it would be our XGuard 2.0, and you would still need to leave the gap of 3 to 4 feet because they're about the same height. If you use your PV kit and XGuard 2.0, that gap could be smaller because the snow retention system would be taller than your solar array. So it can provide, so it can maximize amount of modules on the roof. If you use a taller rail-based system, then you are kind of losing that space, and you are also need to use the more expensive snow retention system. So this is an example where there is a combination of rail-based systems, so higher profile and very low profile snow retention system. The neighbor of this guy was complaining that snow is still falling on his sidewalk. So the recommendation here was to use a taller snow retention system, which was more expensive. So that actually increased the price of this solution or of this project. So here's the beautiful example of using our PV kit and snow retention system in coordination. Mark already showed this picture. This is our headquarters in Colorado Springs. So as I said, we are experts in both industries, in snow retention, but also solar or attachment solution for solar. So we can give you good advice for both system or in coordination of both systems. So that's it from me.
Great, thanks, Mikhail. So just to quickly wrap it up, I guess, is just, so from what we've shown today is that we provide a lot of solutions, and when it comes down to cost savings, definitely consider at least a comparative analysis between direct attach versus rail based, because you'll notice, and once you get more comfortable and again with the assistance and training, it's a big saver overall from time to material and everything we've sort of just explained. So again, if there are any questions that you got that y'all have, feel free to reach out to us. I can, if you allow me to share, I can just throw our information up for another second.
Yeah, just one more question popped up here, fellas. The steps or platform that was built on top of the S5 attachments from the photo of the install in Toronto, is that something you can provide or is readily available? Could the platform become a snow guard after the install?
Well, let me show that picture again. I've got it here.
Okay.
Where did it go? Oh, right here. Can you see that? If I do this, can you see that?
Yeah.
Yeah.
Okay. So you see here, they are gonna put some snow retention on here. They had some fall protection. These were already anchored in. I think they decided this before this was all planned. But you can see here, they built these structures and they could slide them down the roof all in one piece. Pretty ingenious stuff. But no, they wouldn't use that as a snow retention necessarily.
But they built this homemade, but there's available products out there, a company called Metals Plus that has these scaffoldings that can slide up and down.
Yes, yeah, there are a lot of fall protection manufacturers out there that will have actually systems, metal systems that are non-penetrating, reusable. You can take them off, reattach them, and whatnot. So there's our information there. If you want to take a quick snap of it or whatever, and then if you have any questions, reach out to us, and we're more than happy to help on a project or just general questions.
Amazing. Well, thanks again, you guys. We really appreciate your time and the knowledge that you shared with us. I just want to mention, everybody, the presentation has been recorded and will be available on our YouTube channel and then in the next monthly newsletter. Also want to mention, if you've not already signed up for our web shop, please do so. It's a fantastic resource. You can find specs, pricing, inventory levels, install manuals through the portal. You can also view your orders and invoices there as well. If you're looking at S5 stuff, you can find all of their information there as well, and all of our levels across Canada for inventory. So make sure and check it out. And finally, thank you, S5, for your time. You're a fantastic partner with BayWa. We appreciate you guys so much. Any questions that might come up after the webinar, like Brandon said, don't hesitate to reach out to them or your outside sales rep at BayWa, and we'll find a solution. And in the meantime, thanks again, everybody, for attending. We really appreciate it, and we hope you have a great rest of your day.
Thank you all.
Thank you, Jeremy.
You bet. Bye for now.